Hello, this video is the What's My Line Lab. So as I go along and do this, there's going to be a couple of these. There's 6 altogether that I will start but not quite finish. On each one of these, I have put the answer. So if we're going to be doing this in class, but if you'd like to rewatch something or make sure you have it all in your head. So the first thing we're going to do, this is called What's My Line Lab, and I circled the word line. So we have two forms that we use here in calculus. We tend to use the point slope form, which has the slope and a point in it. And we also can use the slope intercept form, which has the slope and the intercept. I tend to use the point slope form a lot, but you can multiply it out and you'll end up with the slope intercept form. So let's get started. Also, before I start, this is where I want you to be at, that I can give you like a word problem or types of things where you can manipulate things to understand a linear functions. So this first one is Jessie knows that negative 40 degrees Celsius and negative 40 degrees Fahrenheit are equal. She also knows that when it says 20 degrees Celsius, it really means it's 68 degrees Fahrenheit. She knows those two data points and that the conversion relationship between Celsius and Fahrenheit temperature is linear. So I know that this is important that you know this. So I know that I'm going to use one of these two forms. What is the equation of the line that contains all the paired conversion temperatures of the form CF? So this is kind of important. First of all, the input is C, the output's F. So that means I should be able to tell you any Celsius temperature and that you could plug it in this formula and tell me what the Fahrenheit temperature is. So my husband uses this a lot because he does a lot of business with Canada, and we don't innately know what certain things are. So he has this like conversion little formula book in his pocket. So the first thing I want you to do is set up two data points. So the first one is negative 40. Oops, I forgot the negative here, negative 40. So there's one of my points. So that's my input, my output, and then 20 degrees and 68 degrees. And notice I put them in the form CF because that's what they said to do, because you could have done this the other way as well. So the first thing I'm going to do is do the slope. And now the slope formula is the change in my y's over the change in my x's. And I want you to realize that you have to start here, but you can go top down or bottom up as long as you're consistent. So I see that's negative. So I always like to do things a little bit easier. So I'm going to do that 68 minus a negative 40. So that's 68 plus 40 all over 20 plus 40 because I'm doing 20 minus a negative 40. And when I reduce that, put that in my calculator and reduce it down, I get 9/5. Okay, so I like using the point slope form, y minus y1 equals x minus x1. So I'm going to now over here put the 9/5 in this formula. So I have y minus y1, and that's the y point. Now, it doesn't matter which one you use, which point, but let's just write this down first. Let's just put the 9/5 in, x minus x1. So now what I want you to do is we're just going to plug in a point. Now, it doesn't matter which one you use. I actually use the 2068. Why? Probably because there's no negatives. So this is my x and my y. So I have y minus 68 equals 9/5 x minus 20. You could have used the other one. Now, what I usually do after I have it like this is I actually multiply it through and add 68. And when I do that, I'm going to end up with this formula, this answer here that I have, y equals 32 plus 9/5 x. Now, the reason why that's interesting, because this is in y equals b plus mx form, and this is my slope, and this is my initial value or my y-intercept, okay? So that's often a more concise way to put it. So this is actually what here's in green is the same as there. But I'm now going to rewrite it in CNF, so like they have. So I basically have the form F equals 32 plus 9/5 C. So whatever Celsius temperature I can throw in there, and it will tell me what the Fahrenheit is. Okay, that's number one. Number two, the equations for two lines are 2x plus y plus 6 equals 0 and kx plus 4y minus 8 equals 0. For what value of k will the two lines be perpendicular? So the first thing I underlined was perpendicular, and because I underlined perpendicular, sorry about that, I wrote down that perpendicular, and this is the symbol we use for perpendicular in math. Perpendicular, which means they form a right angle. Lines have negative reciprocal slopes. Okay, so I know that these two lines will form a right angle. Okay, so how do I get started on this? Well, I'm going to start with the one because they want me to find the value of k. The k is in this one. So basically, I'm going to get it into solve for y, get it in y equals b plus mx form, and then maybe I can figure out to go from there. So I'm going to take this first one. I have 2x plus y plus 6 equals 0. Now I'm going to solve for y. That means I'm going to move the 6 over. It turns negative. That turns negative. So I can write it in this form, negative 6 minus 2x. So basically, I just solved for y, and I quickly got it in that form. Now I realize this is my slope. So if my slope is actually negative 2, that means the slope of the other line, which is this one up here, has to be, you guessed it, 1/2. So here, the slope has to be 1/2 for this line. So I have kx plus 4y minus 8 equals 0. So again, I thought, well, I'm going to solve for y because that's why we do that. And then we can figure out hopefully can figure out what k is. So when I solve for y, I'm going to add 8 to both sides. So I have kx plus 4y equals 8. I'm going to subtract kx on both sides. So I end up with 4y equals 8 minus kx. Then I'm going to divide by 4. Every single term has to be divided by 4. So I have y equals 2 minus k over 4x. So here is my slope, and the sign goes with it, of this line. Okay, but guess what I know it has to equal? It has to equal 1/2. So let's put it equal to each other. So over here, I'll use a different color. So I have 1/2 equals, and I don't care where the negative goes. The negative could have gone on the k or the 4, as long as it's in that. And let's cross multiply. So I have negative 2k equals 4. K has to be negative 2. So basically, I'm saying if I plug a negative 2 in here, this is going to make the slope a positive 1/2, and it does. Okay. Now, number 3, I circled in yellow because this is the exact same problem, except for I have 2 lines here, but now the 2 lines are parallel. So parallel lines, so this is our terminology for parallel, looks like 11. Parallel lines have the same slope. So you're going to do the same thing as you did above, but now the slopes are going to be the same. So you go ahead and do that, work on it, and see if you get k to be negative 9/2. All right, so I'm leaving that for you to do. Have you practice. It's very similar to the one up above, except for the negative reciprocal and the same slopes. Okay? Let's look at now number 4. Okay, number 4 says determine an equation of a line that is perpendicular bisector of the segment whose endpoints are negative 1,8 and negative 5,2. So what I did here is I drew a little picture. Here's negative 1,8 right here. Okay, let me undo that so I don't have yellow here. And here's negative 5,2. And it's a line segment, so I just drew a line in there. Now they want the equation of the line that is the perpendicular bisector. Well, perpendicular, we just talked about, I know forms a right angle, and I know the slopes are negative reciprocal. Bisector means it cuts it in half, or it goes through the middle, which we're going to use our midpoint formula. Okay, so this is what we're going to do is basically I got to find the middle, and then the line that we're going to find is going to form a right angle. So I'm basically looking to find that dotted line. It's just kind of a picture way to look at this equation. So I'm looking for the dotted line, but they gave me some clues. They told me it's perpendicular to this, and it goes through the middle or the midpoint. So the first thing I'm going to do is find the midpoint, because that's quite easy. It's halfway. So I know it's a point. So it's my x's are going to be either negative 1 plus a negative 5 all over 2. So it's halfway between negative 1 and negative 5. And it's going to be halfway between 8 and 2. So it's going to be 8 plus 2 divided by 2. So it's halfway. So now I know the midpoint of that one is going to be negative 3, 5. That's my midpoint, or the middle. Okay, that point is right here, and it's on the line. So I need that point to use. So that's important to say, okay, I found the midpoint, but it's really on that dotted line. So I need that point. It's an X and Y, all right, on my line. Now it says it's the bisector. Oh, we already did the bisector. It's perpendicular. Well, perpendicular has to do with slope. So the bisector had to do with the midpoint. This has to do with slope. Okay. I'm like, okay, I can do slope. I'm going to stack and rack these two things. So I'm going to do those 2 points, -1, 8, and -5, 2, because I like them stacked and racked. And I'm going to find the slope. It's changing my y's, or am I changing my x's? I'm going to go top down this time because it's 8 minus 2 all over -1 and -5. It's going to be +5. So that's going to be reduced down to 3/2. Okay. That is the slope of the segment, of the black line segment. I know if I'm doing the red dotted line that it has to be the, you guessed it, negative reciprocal. So here's my new line. I'm just going to put this here, my new line, okay, that I have to find, the dotted line. I know goes through the point -3, 5. And I know the slope has to be -2/3 because it's perpendicular. Okay. So if I know all that, I can just put it in my point slope form. Okay. So I have y, sorry, I don't mean to keep hitting it. Y minus y1. So my y1 is 5, is my slope, which is -2/3, x minus x1. So it's going to be x plus 3 because that's a -3. So there's my line. And then I multiply it all through. And when I do, so I do the distributive property and then add 5, I get y to be 3 minus 2/3 x. And the other thing I wanted you to know is when I got the slope here to be positive, I knew that dotted line could not be positive because it's going in the wrong, that's not the direction, it's in a negative direction. So that's another way you can check your sign self. All right. Number 5 is circled, very similar. Here's your answer. I'm going to kind of get you started because it's a little bit different in that I have 2 lines here, and the point I need is the intersection of those 2 lines. So let's kind of set this up a little bit different. So I have y minus y1 equals m x minus x1. So eventually, this is our equation. I have to find a slope and a point. How do I find the point? I've got to find the intersection, and then I got to do the slope, which is perpendicular to this. So I'm going to start it because the point of intersection of these 2 lines, so I'm going to help you find the point, and then you can finish it. So I have these 2 lines. I'm going to take this first line, solve for y. So x plus y is 1 is really the point, y is the line y equals 1 minus x. So I solve for y. Then I'm going to take this other line, 2x minus 3y equals 7, and I'm going to actually solve for y. So I have -3y equals 7 minus 2x. And then when I go through and divide through by -3, I get y equals -7/3 plus 2/3 x. Okay? There's my 2 lines. You're like, well, that's not my point. You're right. I have to put them equal to each other. So I'm going to do 1 minus x is equal to -7/3 plus 2/3 x. And I'm basically going to put my x's on one side. So I'm going to add 1x over here, and then I'm going to add 7/3 over here. When I do, I get x to be 2. Now that's the x part of my point. Then I'm going to take and plug it up here and say, oh, 2 plus y equals 1. So y has to equal 1 minus 2, or -1. So now the point that I have for this, so my new line, I'm going to do the same thing. My new line that I'm coming up with, I know has the point to -1. I just found it because that's the intersection. Now you continue on because I gave you this hint here, and it's perpendicular to this. Find the slope and then do the negative reciprocal and put it in your equation. You should end up with this. So I got a good start. Go ahead and work on it and finish it. And the last one on here that I'm going to help you with is number 6. It said if the line 2y plus 5x equals k is the perpendicular bisector of the segment whose endpoints are A and B, find the values of k and t. So I have a k here and a t here. You're like, what? So I basically like to show a picture. Okay. So I just said, this looks like nothing like the graph, but I have A is negative 8t and I have B is 2, negative 3. And it's a line segment, so I just drew that line. I'm sure it's not how it's supposed to be, but it's basically, and what I'm looking for, well, they gave me some hints. They said the perpendicular bisector is this line right here. So perpendicular means the line is going to form a right angle, and it's going to go through the midpoint. And that's what that is. So 2y plus 5x equals k is that. I'm like, where am I going to start? Okay. So the first thing I did is I'm going to find the slope of this line segment to see maybe that'll help me. So the slope of line segment AB is good. And let's stack and rack these points too. So let me erase that. I like them stacked and racked. I just do better. So I have negative 8t is my first point A. My second point B is 2, negative 3. And so I'm going to do slope is the change in my y's over the change in my x's. So I'm going to go top down. So I got t plus 3 is my change in my y. And I have negative 8 minus 2, which really comes out to be t plus 3 over negative 10. You're like, well, that's helpful. I have a t in my slope. That's okay. So I'm like, did they give us another clue? Well, they said this line, this dotted line here, 2y plus 5x equals k, is a perpendicular bisector. So I'm thinking, I know the slope of this. If I can find the slope of this, I know they're negative reciprocals. Okay? So let's see what we got here. So I'm going to make a different color. So I got 2y plus 5x equals k. I'm going to solve for y to see if that'll help me out. So I have 2y equals k minus 5x. And then I'm going to divide through by 2. So I have y equals k over 2 minus 5 over 2x. Now I'm happy because look, there's the slope of my perpendicular bisector. Okay? Here's the slope of my line segment. Guess what? I know they're reciprocals of each other. Okay? So I basically am going to take this and put it equal to a positive 2/5. So I'm not going to really look at this part. I'm just going to look at this part of it, and maybe I should have written it separate. So basically, I'll put a little arrow here. So I have t plus 3 over negative 10 is equal to 2/5. It has to be. All right, it's negative reciprocal. So I'm going to cross multiply. So I have 5t, all right, plus 15 equals negative 20. All right, so then I'm going to subtract 15. So I have 5t equals negative 35. And then t has to equal negative 7. So I found t. I found t, guys. So that's cool. Now I know this point, actually, this point. So I'm happy about that. So I'm thinking, if I know t is negative 7 now, okay, my points A and B are really this. A is negative 8, negative 7, and B didn't change. It's still 2, negative 3, okay? Now I have to find K. Well, where's the K? Well, I'm thinking, wait a minute, I know this. I can now take one of these points and plug it into this equation right here and figure out what K is, all right? I actually could have done it probably, but I'm thinking, wait a minute, if I plug one of those points in there, that's not on the line, so I can't use that. What's the only point I can plug in there? The midpoint. So I'm going to take this A and B here and find the midpoint. So I'm just going to extend the page a little bit so we have some room here. So I'm going to find the midpoint of A and B. So the midpoint of A and B is, add up your x's and divide by 2 because it's halfway. Add up your y's and divide by 2. So I know the midpoint is actually, of that segment AB, is actually negative, let me see, 3, comma negative 5. Okay? Now, that point is on that dotted line, isn't it? Isn't this negative 3, negative 5? So I'm just going to plug it in here. That is so cool. So I'm going to say, ready? 2y, all right, plus 5x equals k. And that, since that point's on the line, I'm just going to say 2 times my y plus 5 times my x equals k. So I have negative 10 minus 15 equals k. So k equals negative 25. Now I know this one's a little bit in depth, but you could read it, watch it again, and take your time. But it's kind of interesting. You can use those to find these certain things. So that's the end of this video, and I hope it helped you.